Good. So thank you. Hello, everyone. My name is Marc. Today I'll present about what TeraXion can do and what we can do, what we actually do for quantum communications. So TeraXion started off in year 2000 with a large focus on the telecom industry and their very stringent quality and performance requirements. So that kind of drove our innovation. And quantum communications just naturally made its way to our activities, naturally, like most of people on the call. So 10 years ago, it was, I would say, sporadic, but now it's a market segment with very high growth for us and already with recurrent business. Otherwise, you can see that we do a lot of, we cover a lot of industries, multiple applications. So how do we do this? Well, we have a strong core expertise and as well experience in photonics. So since 2000, we strengthened our position of industry leader for fiber Bragg ratings. So there's not much we cannot write in an optical fiber. We design our own semiconductors, lasers, very narrow line width, DFBs, around 1550 nanometer. We also master low noise drives and locking electronics. We do silicon photonics, and we're good at cramming all of this into little golden boxes. So with all of this, we develop and manufacture our own products, and we also participate in sometimes huge and multi-year engineering projects. So in terms of products, so we have standard products and we have what we call tailored products that can be tweaked to address very specific requirements. Some of we have platforms that we don't want to say customized, but that's the concept. So we have chromatic dispersion related products, we have optical filters, and we have lasers. And all of them can contribute to a certain extent in QKD systems, like this very generic version of a DV-QKD protocol. For chromatic dispersion management, we have our standard fixed and tunable compensators, slope matched to the SMF28 fiber. Very important to control the time envelope of pulses over long distances. We also have lab units for R&D, so they can emulate thousands of kilometers. So we have one box that will reach 2,600 kilometers, for example. And we have also fixed and tunable. Then we have pulse stretchers that can find many uses, most often for entanglement-based protocols. So you have different length for different paths. So you want to resynchronize your photons. But also, let's say you have a pulse, you want to switch from frequency domain to time domain to collect your pulses sequentially. So those are obviously very highly tailored products. Optical filters are getting more and more attention. What's fun with QKD is that everything is needed all at the same time. So you need very often narrow bands, well-defined filters to work around spectral features and avoid picking up basically any interference. The isolation needs to be extremely good. You need low insertion loss because every single photon counts. You need high reflectivity, either to extract your signal of interest, the entirety of it, with a circulator, in that example, or to strongly suppress a pump or a carrier and transmit only your signal of interest. This method, when applicable, you can reach like less than 0.1 dB of insertion loss. The fiber itself has very low loss. And you can have an isolation of up to 60 dB with a single FBG. So let's say you have two FBGs and an isolator in between, then you can reach that 120 dB that we're often asked for. And then you can use the FBG as is, So you have the recoated FBG. You can use an thermal package. We have a bunch of them. So that will drastically improve the thermal stability and limit the wavelength drift to 0.7 picometer per degree Celsius. Or you can go with the tunable module. So the pinnacle of wavelength precision and stability. So that's 2 picometer accuracy and a stability over 24 hours of 40 megahertz week to week. So those are the options. And now I can present our new generation of narrow line width lasers that was presented last OFC. So for this one, we started with our own chip. So an intrinsically narrow line width. We used a frequency discriminator in a butterfly package. And we used our new electronic platforms as well, integrated all of this into a little box the size of a credit card. So what you get is a very compact and rugged laser, easy to use and integrate for testing new protocols and system designs. And as some customers did with the previous generation we had, they used it to get to the market very fast with high performance. So interestingly enough, this laser has the line width of a fiber laser and the range of a DFB laser, which it is. And like I said previously, in more than 20 years, beyond our own R&D projects, we worked on numerous engineering contracts, with very complex design and assemblies. So silicon photonics, we played with that since 2009. Since then, we've developed a bunch of building blocks, and we used it. We probably locked everything there is to lock. This little hockey puck that you see here has 3 lasers locked onto each other. And then, of course, all the integrated photonics and electronics to handle, I will say, extreme performance requirements again. This, by the way, implies that we need to excel in testing and perform all these electro-optic measurements for our products to push the boundaries, because that's what we are asked for. This project and many others are just a good example of our packaging capabilities. So we're used to combining all of our technologies. So you have lasers, FPGs, or other frequency discriminators, silicon photonic chips, and we can beautifully integrate it. And now, in fact, in package much smarter than this. This is what we can show. But in the end, the concept is that we don't shy away from challenges if we see a good fit with our expertise. And because we want to stay at the forefront of technological development, we want to help, and we can help. So we can help with laser development for locking / stabilizing / synchronizing lasers. We're good with design, integration, and testing. And where you can help, well, we're always open to know about new components. I wrote micro-optics here, but any components we could integrate. And directly, for system vendors, QKD standardization, that could lead companies like TeraXion, for example, to commit to some designs, components, and modules that you could use for next-gen systems. And of course, discussing with you guys provides insights and opportunities for us to help you better. So we are always open to collaboration and partnerships. So that's it. Don't hesitate to contact us or visit us in Quebec. If you are curious, we have our new colleagues in Switzerland as well, Exelos. So thank you all.